All right, and we are live. And today we speak with Chad, also known as Kudzu. Hi.
Hi, how are you?
Good, how are you? You should stop sharing because now we see your PowerPoint still.
Okay, there we go. Is that better?
Not yet.
Screen share. Are we there?
There you go.
There
we
we
can
are.
see you. Excellent.
Okay.
So why don't you introduce yourself and tell us a little bit about yourself and what you're usually doing, and then we'll switch to Cosmos.
Well, boy, it's kind of a long history. I used to work for Microsoft. I was the regional developer evangelist, and I had a territory of 85 countries. I covered the Middle East and Africa. I had to resign that position because we had some family and medical issues, and since then I've just been independent, and I work on Cosmos and several other open source projects.
Excellent. So what is Cosmos?
Cosmos stands for the C# open source managed operating system, but it's not an operating system itself, and it's not even limited to C#, but we'll cover that as we go through. It's actually a set of Legos for building operating systems using .NET.
Legos.
Yes. So the idea is you can use Visual Studio and write a program and boot it directly as an operating system. And the goal is eventually that people can write their own mini or even full operating systems.
So is it mostly in order to deploy C# code with as small a footprint as possible, or is it really to build the next Linux or Windows?
It's both, actually, and it's not limited to C#. C#'s in the title, but that's what we use to build the kernel pieces, etc. But you can use Visual Basic.NET or F#, manage C++, etc.
Okay.
So the goal is that we're trying to build an operating system around more modern concepts, because the operating systems of today, whether it's Linux or Windows or iOS, etc., they're all basically around the Intel architecture, and they have a lot of legacy things inside of them because they have to run older executables, etc. And we really wanted to approach an operating system from the very beginning and think about what concepts we could change. For example, we've done some tests, and this isn't in the Cosmos core yet, but when you get down to the assembly language level, people are still using the C calling convention, which has a lot of overhead. And of course, compilers can inline functions, etc. But by messing with the calling conventions and getting rid of a lot of these legacy things and providing a lot of the protections that Windows and Linux have to rely on the hardware for, we can rely on the software for. Since we're fully managed, we can execute a lot faster. And I've done some demos where I've had code run 20 times faster than equivalent C++ on Windows, just because we control the execution at such a high level, and we can move the hardware protections, which are actually very expensive to run on the CPU, into software, since it's all managed code.
So security and performance seem like those would be the most notable benefits at the beginning, right?
Well, I would say they're a core goal, but I wouldn't say at the beginning, because right now we have so much debugging code, et cetera, that if you run Cosmos right now, I mean, it's really slow because there's so much debugging code. But as we approach the 1.0 and the 1.1, then absolutely yes.
When do you see that happening?
Well, it depends a lot on the resources that we get, because right now the problem is everybody wants to put the cart before the horse. Everybody's coming in and saying, let's build a GUI, let's build some games. And the problem is, when you don't have memory management fully functioning, it doesn't make sense to work on the graphics. And so we need some more low-level developers. We have hundreds of developers within GitHub, but a lot of them, they're all wanting to work on the, the fun stuff. And we still need to be working at the base level. So we need some more developers along there. And the last 4 years, I'm one of the co-founders, and I'm normally one of the active coders, but I spent about 4 years with a long-term medical problem, and I'm just on the recovery now. So I've kind of been, for the last several years, and just working on architecture and consulting and mentoring, those sorts of things. So as I become more active, we hope to see, I'm hoping to get a 1.0 out in the next maybe year.
Okay, so let me ask about something you said. You said hundreds of developers. Did I hear that right?
Yes, but they're not always all active, and a lot of them are young kids. We somehow, we didn't target this, but we are attracting a lot of teens and a lot of preteens, and I mean a lot. Probably
awesome.
Half the people we have in there are teens and preteens. I don't really know. I think it's because at that age, developers are still full of hope and wonder and optimism, and they look at our project and they just go, wow, and that's what they want to do. And so we want to move more to foster them, because it's really a different kind of audience. And a lot of the developers in the project, that's where we came from as well. but it takes some extra resources because a lot of the people coming in and using Cosmos and programming operating systems, I mean, they're still learning C#, and all of a sudden they're developing operating systems. And it's really cool that Cosmos lets them do that, but because they do that, they ask us a lot of C# questions, a lot of other things. So we need to we need more help in the community to be able to help these people along and understand that a lot of the developers we have, they don't necessarily understand even a lot of the C# or VB concepts yet, let alone operating system concepts. But the fact that Cosmos is letting them write an operating system without even knowing much C# or VB, I think is kind of amazing.
It is absolutely. And actually, I can see this as an opportunity for people out there who are looking for meaningful contributions to make, actually mentoring young people and teaching them how to develop and how to build something as amazing as an operating system. That sounds like a very, very valuable contribution to make.
No, absolutely. It's very exciting. If we could just get some more developers kind of on the foundational level, that's kind of where we're held up now, because we only have, I don't know, maybe a dozen, and maybe half of them are active at any one time. So maybe 5 or 6 developers that are really active in some of the very, very base framework areas. And sorry for the move, but we can mentor people. So a lot of times people come and they say, well, I don't know how to do assembly language, or I don't know how to do some of the core things you really need help with now. But the thing is, the co-founder that I work with, when we started, he didn't know assembly language at all. I mentored him, and now he knows assembly language, like the back of his hand. So we're willing to help people out, and not everybody has to do these base tasks. But if people want to see a 1.0 and a 1.1, 2.0, et cetera, we need to get the horse before the cart, and not the other way around.
I see. So as I was reading through the FAQ, one of the things that made me think was what it says about shared memory and how to take objects around between processes. And can you tell me a little bit about that? That sounds very interesting from a technical standpoint.
Well, in a traditional Windows application or Linux, or take your pick, what happens is every process gets loaded into a separate set of virtual memory. And so it's in a protected space, but that's a hardware protected space. And that actually requires a fair bit of overhead on the CPU and a fair bit of circuitry in the CPU as well. Let me digress. It actually kind of ties you to the architecture. So if you write to that architecture for Intel and then you want to run on ARM, ARM has a totally separate mechanism for doing that. And so it sometimes influences the operating systems or creates portability problems. What we do is we totally ignore those sections of the processor. We don't use virtual memory in traditional sense. We don't use hardware protections. We don't use even the user and the ring levels in the CPU to control those things. That's all enforced by the Cosmos kernel itself. So by doing that, it's much easier to share objects, because everybody lives on the CPU level. All processes live in one huge virtual space, but they can't touch each other because they're protected from each other by Cosmos at the software level, because the only input is managed code. Now we convert it to native code, but we never allow loading of native code that we did not produce ourselves from managed code. So the only way into Cosmos is managed code. And because of that, our compiler and our execution model allows us to duplicate all of those normal memory protection functions, security, et cetera, within our operating system itself in a much more efficient manner. And not only that, but much, much more flexible manner, because the way that the CPUs do it, as they do it in hardware, it's a very rigid, limited model.
Okay. And so the way I understood it in the FAQ, it seemed like this had huge benefits potentially in terms of I/O, for example. It says something about eventually having the fastest web server on the planet. Is that a realistic goal? And how would that work?
Well, I think it's very realistic, and this comes back to the fact that our code is able to execute faster because it doesn't have this overhead of task switching at the CPU level. For instance, we talked about memory protections, but even things like task switching at the CPU level, it's got to save off your stack, it's got to save off the flags, it has to save off all these things and do a task switch. And they have gotten them to be pretty quick, but if you look at the impact on the code, it may not be massive anymore, but it's still significant. Since we don't have to save all of the things the hardware does and switch at a hardware level, we don't have to interrupt the process in a hard manner. In other words, when the CPU interrupts processes, it just says, I'm interrupting you right now, and it interrupts you between an instruction. We can control the granularity at which we get interrupted, at which we task switch. So we don't have to do it at the assembly level instruction. We can do it at the IL instruction, et cetera. So we have to save fewer things to do a task switch. And since we're not doing a forcible interrupt, it's much, much more efficient that we're able to task switch. Now, some of this is the future in design. So for instance, when we get to the slides, I'll talk about this. We don't have threading yet. So a lot of the things I'm talking about are plans, things that we have tested, but aren't into the code itself yet, but they will progress into the code in the near future.
Okay. Do you want to switch to those slides?
Yeah, let's switch over for just a second. And let's see. Okay, share. Okay, can you see it now?
Yep.
Okay. So as we said before, Cosmos is a C# open sourced managed operating system. And let me get to, okay. So first of all, people are gonna ask me why I'm not doing live videos. The first thing is I have 2 internet connections. They're both extremely spotty. And for me to do live video at higher definition is just, it's a recipe for disaster. So what I'm going to encourage people to do is download this and try it for yourself. It's really easy. It doesn't require a lot of, it's not like trying to compile a Linux kernel or install a Windows driver into the driver development kit using C# sources. You download it, you run it. There's a few prerequisites you have to install, but I would say it's actually easier than installing Visual Studio itself. So if you can install Visual Studio, you can install Cosmos. It's extremely easy. Okay. If you want to see the videos, there's quite a few videos on YouTube, not only from myself, but a lot of users have put up videos of things they've done. They're building Snake games and a lot of console games. Some users have built some basic graphics, VGA and VBE drivers, etc. So you can check on YouTube for these.
Okay.
Despite the name, you can actually use any managed language to program Cosmos. So you could use C#, VB.NET, and we don't have the project templates right now, but this is the type of thing that somebody could help. They could just come in and make the templates.
Just so you know, you're not projecting your slides right now.
Oh, they're not showing? Did they? Hold on, what happened? Okay, are they back?
Yes, they are.
Okay. Well, if they go away again, just let me know.
Yeah.
Okay. So basically, if somebody were to come in, there's a lot of small things. So Cosmos will support managed C++, F#, and others. Someone just needs to make a project template, and that's not a very difficult task. It's basically telling Cosmos, here's another language, and when you do a new project, here's the shell of what needs to be there. And they're fairly standard projects with some small changes, so it's not a big task. But the basic idea is you can use any fully managed language with C#. The C# name in the title refers to what we use to build the whole Cosmos itself. And besides that, Nosmos or Vabosmos just doesn't have quite the same ring.
Yeah.
So here's some demos. I'm going to show you the images again, just because I want the demonstration to go properly. If you want to see these, there are videos on YouTube, and you can download and play with yourself. Sorry, not play with yourself. Play with the demos yourself.
We'll put links in the description. You just send me the links after the show, and I'll put them there.
Okay. And I'm sorry if it's a little bit fuzzy. I'm running on I have a 5-monitor setup, and my main monitor is a 32-inch 4K monitor.
Wow,
so
lucky you. I wish I had that in my office.
I resized it down to 1280 by 720, and some of the images got a little bit fuzzy. But I think you can see here.
Yeah,
this is, of course, Visual Studio. And you can see I have a project called Guess. And you can see that the code here is pretty standard code. I have what's called a run method, a before run and an after run. So when this program boots, as we say, it'll run before run once. And then it will run, which is right here. It will run this. Let me turn on the annotations. Pen. Okay, so basically, this is the run method. And that's what's going to run. It'll run repeatedly. It'll run in a loop. So you notice when I get to the end, it'll loop back up. If you don't want to do this, you need to put in the logic to handle it, etc. But you can see it's all standard code. There are some extra calls here. For instance, you can communicate directly with the debugger. I'm sending just a blank line to the debugger. And I'm sending another thing. And these show up in the console window. So they actually execute on another machine or in VMware or Box or Hyper-V, those sorts of things. But this will send a message back, and this will show up in the Visual Studio console output. So you can send your own debug messages. So you can see here I have access to the console. I'm just writing out. It's all standard C# code. There's nothing really funny here at all. So let's go on to the next slide. Now, if I hit F5, when I hit F5, what happens is this. You can see it running in VMware. Now, it also supports BOKS and several other emulators. It's not a big deal to upgrade to Hyper-V. Hyper-V is on our list again, but right now, we use BOKS and VMware mainly for development. And so this is actually something running in VMware directly, and it also does run on direct hardware. Okay. So you can even use breakpoints. So all these screenshots, I took about an hour before speaking to you. So these are all things that were done very recently. You can see I put a breakpoint. And when I input a number, if the number was too low, and I did this in VMware, it would break in Visual Studio, just as it did here. You can see the breakpoint.
Great.
So it broke right here. And then you notice I have watches.
Yeah.
Now that is actually running on another machine, in this case, a virtual machine. But even when you're running on physical hardware, if you connect them up by serial port, the serial port can be used to do all the watches, debugging, etc. So you can debug live hardware this way. And I have some demos on the code project for this.
What is the smallest piece of hardware you've run Cosmos on so far?
An Intel Edison.
Nice.
But we don't support the Intel Edison anymore. That was just experimental. And we did that about a year ago. And for now, we've given up on the Edison and we're focusing on other things. But we could support the Intel Edison again in the future.
Yeah, I was mostly asking to get a sense of how low you can go in terms of footprint.
Oh, in VMware, I think the VMware image we run in, I think has 256 megs of RAM. I've run them in smaller ones, but usually I just set up 256 megs to run it. So it really depends. Right now, everything in Cosmos is a monolithic kernel. So basically everything gets compiled in. And the basic images, I don't remember the exact sizes offhand. Maybe when we're done, I can go through and I can pop up one of the images for you. We can do a little exploring and try to see if my video will hold up. There's a ton of debugging information in there right now too, but our goal is eventually to be able to run on tiny little microservers, et cetera, as well as normal desktops. And right now I mentioned that our debug connection only, if you're doing real hardware, you need serial. I have some slides I'll show you that in the future we'll be able to debug over Ethernet too. But the problem is the debug code has to be handcrafted assembly because it has to run independent of Cosmos. And so it's not very large, but there's several screens of hard-coded assembly. And it's much easier to work with a serial port than it is Ethernet. So we have to write an Ethernet driver in assembly to be able to do the assembly level debugging. But you can see we have the watches, and you can see even here, we have a call stack. I can step through this code. I can use F10 and F11 to step through this code as I go while the code is actually running on a different machine. So this value of 4 was actually brought to us from the other machine. It's not executing on my machine where I'm developing. Okay, so next slide. Let's see. Okay, sorry, small bug with PowerPoint. If I use the pen, it won't advance. I gotta use the mouse. Okay, so Cosmos has a few extra things it adds in as well. So in Visual Studio here, you can see there's a Cosmos menu, and I have some extra windows. Now, most users would never need these extra windows, so I don't want to scare anybody off. But when you're developing Cosmos, if you're down in the deep frameworks, and let's say there's a bug in the compiler, which it happens from time to time. Bugs happen in the compiler. So we have extra views that we can load up assembly windows, registers windows, and stack windows within Visual Studio. We can even trace them, and they look like this. So you can see down here, I can look at the actual stack of the CPU. And these are red because they all changed since I last stepped. So basically, they're color-coded whether or not they change, so you can signify changes very quickly. Here are the registers. Okay, and here's the actual assembly that is happening for the line we're on right now. And the code is at this point. And so I can step using the Visual Studio. If I want to step through C#, I use the buttons or the Visual Studio menus.
And you can have both windows at the same time, and they're in sync. And
yes. So if I want to step through the assembly itself, I can use the buttons right here. And you can see I have several buttons for stepping through. So I could actually step through the assembly line by line, and it would update these windows as I went through the assembly as well.
That actually looks like a great way to teach people about the assembly language and
absolutely,
and
I never thought about it
compilers.
that way, but absolutely.
Yeah.
So these are some of the extra things we have built in, but remember, most users wouldn't need these, and this is just I'm glad everything went well so far.
All of us.
Let's talk about the bare metal. This is, I have several PCs here. If I were to show you my whole office, it's such a mess right now, I don't dare show anybody. But I have about 7 or 8 PCs in here. And this is an old PC I have. This is a standard Windows, a standard Intel PC. It's in a micro ITX board. But this PC used to run Windows. You can see it's got a hard drive in it, etc. But this is a PC I use for debugging when I'm running on real hardware. Now, I could compile to a flash drive and pop the flash drive over in this PC every time I wanted to boot it. The problem is, that's great for a demo. It looks great. But when you're debugging and you're recompiling multiple times every hour, it really gets old. So you can see over here, I have a custom circuit board here. Okay. Now these cost about, I think this board cost me about $20 or $30. And there's an article on Code Project that details exactly how to interface the computer to this board, and the software is all built on the Cosmos. And let me show you what this board does because it's really cool. But I want everybody to understand this here is a normal PC. It looks small only because it's a mini ITX board, but otherwise it's a normal PC. And what we can do is, you can also stick it. So I took the same board and I stuck it in a bigger case here, and I hung my board up here, okay? So this is the custom board. This board is not required to develop on Cosmos or run Cosmos. What this board does is it helps me debug Cosmos faster. So instead of having to put in a USB stick or burn a CD, or even just use an Ethernet cable, because you can plug an Ethernet cable between your computer and this, and you can boot over DHCP with boot P. So basically what you would do is you would run Cosmos, it would wait to see the server, and then you have to reach over and turn the power button on. And when you turn the power button, it would come up and boot Cosmos automatically directly out of Visual Studio. Visual Studio and our plugins would send everything over the Ethernet and boot it directly. But that seems like that's a lot of work to be touching that button a lot. It doesn't seem like it, but it is. So this board here actually controls the power of the computer. And our plugins in Visual Studio will actually turn the computer. Yes, this little board will turn the computer on and off for us. And when I'm in Visual Studio, so when I press run, it'll build, turn on this computer, upload it, start debugging, and if I press the stop button in Visual Studio, it will power off the computer.
That's actually pretty cool. Why do you need 4 relays to do that?
Well, when I say it's a custom board, it's a board you can buy directly off of. Yeah, so I didn't build the board. I built all the wires, and I built the software to talk to the board. Yeah, but you can buy this board as is. I think they're about 20 or 30 US. And there's an article that lists all this. So I had to do the custom stuff. But it has 4 relays because that's just how the board comes. I'm not using all 4. So what happens here is, here's what I've done. Basically, on motherboards, there's a connector where all the wires, so all the wires from the front of your case normally connect in here. Okay, and you'll see that these 2 are normally the on-off switch. You've got the power LED and some others. So these are what the cables normally look like if you were to pull up in your PC. And what I've done is I've used the relays and I've spliced the wires and I've replaced them. That basically the relays control the switches instead. And then from here, this is connected over another serial port to the developer machine, and the Cosmos code controls all the relays here to turn the PC on and off as needed.
Right.
So
that probably takes less than 5 minutes to set up.
Well, a little more than that, but not much.
When you know what you're doing.
Yes. And for people who want to do this, I actually have on Code Project, if they search for me by name and then search for Cosmos, this one's called Controlling a Remote Slave PC with Cosmos, I think. And it has a complete tutorial, including a video showing this whole thing in operation. And I actually took the screenshots out of there. So you can see the PC. So the back connections, this Ethernet here is a crossover Ethernet cable. And this is what is used to, when the PC turns on, it will get a DHCP address from here, and using boot P, etc., it will then load up the image that Cosmos sends it and boot it automatically. This cable here is used for debugging. This is used to set the watches, do the stepping, everything that Cosmos does back and forth. In the future, hopefully this will be able to use the Ethernet cable, but as we discussed before, that's a bit of work.
Yeah, but that will have to work at some point, because motherboards nowadays don't have serial anymore.
You can use USB to serial in some cases.
Right. Yeah.
Actually, no, for this one, sorry, for the debugger can't be USB to serial. The other one can be. This has to be raw. But what you can do is you can plug in a PCI card.
Yeah, exactly.
Etc. Or you just buy a board with a serial port. Yep. You're right. A lot of boards don't have them, but many do. And a lot of boards that don't have them, what they do is they have a serial header. So what you can do on my actual machine now, I have a serial header, and then I just have a header sticking out right here that plugs directly onto the board. And sorry, this is the monitor connector. This one is the serial cable for debugging. And then this cable here is actually a USB cable that plugs onto the relay board. So those are the only 3 connections you need right now. And in the future, we'll just need 2, just this one and this one. So if you're going to do live hardware, yes, you do need a hardware that supports serial of some sort, but you can find these boards on eBay for $30 or $40. Even new, you can find them on Amazon, so it's not a big deal. So basically what I've done is, this is one of the relays, and I've wired in the power switch. But sometimes I want manual control, so I still have a manual switch which I can override things with. And then here's the header we looked at later, which all the wires go to. And then these are basically connected to there, and I have it connected to the power lights down here. And in the newer one, this has sensors on. I've connected the power. Oh no, it's up here. You can see it. I've connected the power light to one of the inputs, so I can actually tell when the PC's on and off as well. So the software in Cosmos not only turns on the PC, but waits for it to come on. And when you do a stop, it can tell if the PC's on or not.
Nice.
And then this is the cable that goes back to my developer machine. That's USB, and Cosmos talks to the board using that line right there. And the link is at the bottom of the slide right there. If you go to there, you'll see the video and everything.
Okay, so all that is pretty cool, but you don't need to do that just to play with Cosmos, right?
Oh, no, not at all.
If you want to run it on actual hardware.
No, yeah, you can run in VMware or Box. And if someone, at one point we did support virtual PC and a bunch of the others, but what was happening is the developers were mainly using VMware and Box. And we use Box sometimes because Box is an emulator. It's not a virtualizer, but because it's an emulator, it lets you do lots of cool, tricky things to the virtual CPU. It has more advanced debugging features than VMware or Hyper-V. So sometimes when we have a really sticky core problem, we'll use Box, but mostly we use VMware. But Hyper-V is on our list, and it's not really a big deal. Somebody just needs to basically, there's a plugin structure. Somebody just needs to go in and add an option screen for it, and then add a few lines of code to start up the Hyper-V image, stop the Hyper-V image, and set up the virtual serial connection. That's really about it. And it is on our short-term roadmap because we want to get to Azure.
I see. That makes sense.
So that's the end of that slide. I've got a few more slides. Maybe we could just run through them, ask questions as we go through, and then at the end we'll have time for more questions. Does that sound okay?
Sure.
Okay, so the history of it is originally in the early 90s, I was mulling around and doing a lot of designs of something called Chaos, which originally stood for Chad Howard's Advanced Operating System. And that's what I was working by myself. And I really didn't think it was fair to stick my name into the title because I wanted it to be a team effort. If I stuck my name into the title, it wouldn't be a team effort. So around 2006, I was pondering it again and talking with a developer that I work with a lot on some projects. And we got this idea that, well, really, there's .NET managed code, and there's a lot of these things, and it caught up to where we needed to be. So we decided to go forth, and we did some experiments. And the first thing we did was write a compiler just as a proof of concept. And once we got that working, we said, okay, let's go. And it was just 2 of us. And so I named the project Cosmos, C# Open Source Managed Operating System, and we started in 2006. And it really took off really, really fast from there. So from a technical standpoint, the only thing that's not ours is the bootloader, and this confuses a lot of people. So I want to be really clear here. When you first boot Cosmos, you'll see something comes up says syslinux. It's not Linux. We are not running on top of Linux. Syslinux itself is actually a bootloader. It's maybe inappropriately named. It is not Linux. It's not even a miniature Linux distribution. It's just a bootloader like Grub or even the Windows bootloader. But the reason we use syslinux instead of Grub, well, first of all, there's the GPL issue. And as a team, we're not fond of GPL. Everything in Cosmos is dually licensed. It's BSD license and also MPL. You can choose which license you want. And both those licenses are extremely permissive. And both
MPL being
Mozilla Public License.
Yes.
It has a few restrictions, but you're fully allowed to use it for almost anything you want, and you can even use it commercially. Both licenses do allow commercial usage. I prefer the BSD license myself. The BSD license basically says you can do whatever you want with it as long as you don't take credit. And somewhere, it doesn't have to be in your splash screen. It just has to be somewhere in your documentation. You just have to credit the team, the Cosmos team, for creating it, and that's it.
It's attribution. It's pretty much the same as MIT.
Similar, yes. So with syslinux, again, it's not Linux. It's just a bootloader. It's only used to initially, basically, the boot P, the boot off of hard disk, et cetera, all handled by syslinux. And then what it does is it hands it directly off to Cosmos. So it does the real mode switches, et cetera. And once Cosmos boots in the second stage, syslinux is completely removed from memory and it's not used at all. As far as execution, we talked about quite a this before, but it's fully managed execution. It can support any architecture, whether it's Intel or Motorola or ARM, etc. And we can run without the legacy concepts. And because of this, we have a lot of speed. And this is what we talked about earlier. Now, one of the things is, one of the components is called IL2 CPU. Mm-hmm. This is a compiler of sorts. It takes the IL. So when you have a C# program or a VB, it creates an assembly. And inside that assembly is IL, intermediate language. It's not assembly language. It's a platform neutral code that .NET normally will JIT, just-in-time compile. What we do is we pre-compile it, and then we load that image. In the future, when we get IL2 CPU running on Cosmos itself, we won't need to pre-compile except the base kernel, and Cosmos will pre-compile and load the images as it needs them, and it'll also be able to recompile individual pieces to optimize, just like the JIT does, but with actual native code. So we are pre-caching. You might think of it kind of how .NET does NGen, but without all the limitations. And also, since we're not running on top of another operating system, we don't have to deal with all the hardware overhead or the legacy concepts of calling conventions, etc. And a lot of people ask us, why don't we use Lex or Yak or many of the traditional compiling tools? And the reason is IL is not a text-based compiler. So it's tokenized, and we have our own parsing system for it, and it's queued, etc. It's not multi-threaded yet, but it's quick enough. It's rather quick. So one of the other pieces is a thing called X#. And X# is it's a high-level assembler embedded into Visual Studio. And this is the only part that is Intel specific. So there are Intel specific parts of Cosmos, but they're deep down in what we call ring 0. It's an extremely limited section of Cosmos that users cannot touch. Only those working within Cosmos, the core, can touch this. And we minimize the amount of assembly code we have. Right now, as far as X#, there's probably, I would say there's not more than 500 lines of X#, not counting the compiler, not counting IL2 CPU. So as far as actual embedded code, I don't think there's more than 500 lines because it's absolutely minimized. And most of it's in the debug stub, which is completely separate from Cosmos itself. It's what communicates back and forth and has to run at a very basic level. So it looks like this. Now, the reason we use this instead of Intel is I personally find Intel mnemonics ugly. I've never liked them, even since the early 90s, even late 80s. I was programming assembly in the 80s on the 186s and even the 88, 88s before that in Z80s. And so we have our own high-level assembler. So instead of having to say load EAX, we have this concept here. So you can write
I'm still stuck on 6502 myself.
Well, I started out on 6502, and I much prefer Motorola, but of course, nobody's using Motorola anymore. From the 6502, I was actually in the 68000s, and those were beautiful. And the Z8000s and Zilog were even better. Yes. But this is all Intel assembly. It's just our own mnemonics, and it's in Visual Studio. So this is actually part of the debug stub. And you can see it's a high-level assembler because we have things like if statements, which will get translated into full assembly, but give us syntactic sugar and make it a lot easier for us to work on. And so this is a variable which represents a memory address getting loaded into EAX. And you can see we can even do comparisons.
So would it be fair to say it sits somewhere between IR and actual assembly in terms of?
No. This is actual assembly here, and this is only used in a few spots within Cosmos. We don't use this in most places, so most developers never see this. This is only in the very deep core of Cosmos. But the compiler and the few spots that have to be hand coded by assembly, we write in these. It makes it a lot easier on us. But it is x86 assembly. It's a high-level assembler, which basically means that, for instance, this line right here will translate to a single x86 operation. Most of them will. But some statements are compound, like this one. This will generate several x86 instructions, but it's very predictable what it will construct for you.
So it's a very, very thin abstraction over.
Yes, it's called a high-level assembler. It's a very thin abstraction, but it's sitting right on the hardware. And by running it in Visual Studio, we have syntax highlighting. We have the # to compile it right, and you can see the files have a .xs extension. And so this is Intel specific. When we support ARM, we'll have something else probably called A# or ARM# or something along those lines. And the goal is to keep this very, very minimal, because when we port to different platforms, we don't want to be in the position of having to port thousands or millions of lines of code.
Since that is the only part.
Lines.
That is the only part of the system that you have to port, correct?
Yeah, so we port 500 lines. And in the future, I expect this will probably grow to several thousand, but I don't expect it to ever go beyond 10,000 into the millions or anything that's really difficult. And once you port this and you port the compiler, everything else will run. because we're basically neutral of the architecture.
Very nice.
So that's X sharp there. And I don't want to scare people. Most people will never ever have to touch X sharp. But if you're into the core, this is just stuff that is just I find to be really cool and a lot cleaner than having to write the assembly by hand. You can write assembly by hand as well as you want. Another concept is called plugs. For instance, in the .NET framework, there's a lot of calls that end up making Windows API calls. And we have to replace those because we're not running on Windows. So we have what's called a plug. So for instance, and you can plug things, sometimes they're not even Windows calls, but you just do them differently. They're done in Windows. So we have here is we have a plug. So this plug right here, using this attribute, tells it, we're going to plug this class. Okay? And so basically, the background color property is overridden. So instead of using the .NET framework, our compiler will swap it out and put this in its place instead of the version in .NET. And this allows us to use a base class we have for interacting with the screen, instead of interacting with what Windows would consider the console through a Windows API call.
Okay.
And we try and keep these C# as much as possible. So current GPS and travel plans. Right now, as I said, if you run Cosmos, it's not going to be fast. Okay, we know that, and that's because it is absolutely full of debugging code right now. So I don't want anybody to get Cosmos and say, "Oh my gosh, it's so slow." I mean, there are builds you can download, and you can watch it spit out the characters in the console. I mean, like an old modem type, the 300, 1200 baud days. It's not always like that, and it will not be like that as we approach release. We know about it. We know where the optimizations are, and it's because right now we're still focusing on building some of the, the frameworks, and we need all that debugging information. So don't anybody get scared. They look at it and go, "But you said it was really fast, and I can see it print on the screen." Well, yes, you can, because all the debugging information is there. Until we remove the debugging information, it's going to be slow. So at this point, I still think Cosmos is very academic, but I think within a year we could be to the point where some users could run limited things in production as long as it fits within the features that we have. So we're focused on the foundations. We have the console, the debugger. And that's the other thing people come to. They say, "Geez, it's been like 2 years. You can't get graphics yet?" Well, you know what? There are other projects that have graphics, but how many other projects have stepping and watches? That's been our main focus, is we want this to be a true rapid application development operating system building kit. And to do that, it's an amazing amount of work to get all of this running in Visual Studio. And that's where we're really, really focused. Aside from that, we're focused on right now what we call Fat Rat Core. And these are actually 3 concepts. The FAT is file allocation table, which means disk access. So we can read, FAT disks. RAT, that's our memory manager. It's called the RAM allocation table. And Core, this is .NET Core. So right now we're running on normal .NET, but we're going to switch over to .NET Core. And the reason is the plugs. With .NET macro framework, or the primary one everybody runs, there's a lot of stuff we have to plug. With .NET Core, because it's designed to be cross-platform, Microsoft took a lot of the native code, rewrote it in C#, and they basically minimized the number of external calls into the host operating system. And so by moving to .NET Core, we have a lot fewer things to plug. And we're in the process. We're very, very close. One of the main developers is working on that right now. And I would say within the next few weeks, or hopefully by the end of the year, we'll be on .NET Core. And then we have to go through and remove a lot of plugs that we wrote, et cetera.
Nice.
But we don't run, when I say we run on, we'll be running on .NET Core. Sorry, when we're running on .NET Core, we do not run the .NET Core execution. And even on the .NET Macro Framework, we do not run using the Microsoft execution engine. We do not use that. All we do is take the assemblies and compile the IL. We run within Cosmos itself. So by changing over to Core, the biggest thing that's given us a loop is the project formats are different, and there's still some things that don't fully function in Visual Studio, and we're just having to adapt everything over to it. But on both the .NET implementations, we are running only within our context, and we just basically parse the IL and bring it in. That's the only thing we do with it. Everything else in the .NET framework, we throw away, the execution engine, et cetera. So the RAT, that's the RAM allocation table. That's almost done, so we almost have full memory management. It uses 3 modes to store memory. It's a hybrid type. It has slots, heaps, and several other things depending on how the how big the object is, how frequent the object is. And one really cool thing we can do that a non-managed operating system can't do is we can move anything in memory. That's a huge problem within Windows and Linux, is the heap, because you generate these object files and sometimes these objects in memory, and a lot of times they're stuck. Now, if it's a .NET object, .NET can move it, but Windows can't move it. So when you get the non-managed objects, which .NET, of course, uses a lot of implicitly, Windows can't move them around because they're based on pointers. We're not based on that. We use handles for everything at the operating system level. So anything in memory can be moved around. And it's very, very efficient in this manner because we get a lot more memory usage. If something is, right in the middle of a big block, we can move it. It's not a problem. And it's a system that's designed to move these things very, very fast using indirect pointers. And even though we're having to go through a level of indirection, it's still just as fast because although we lose slightly on that aspect, we gain it back in other optimizations. And then FAT, everybody hopefully knows what FAT is. It's a file allocation table. And eventually we'll have NTFS and EXT2 and be able to mount other disks. But for simplicity, we stuck with FAT for now. And this was actually a user demo. This isn't even one of mine. This was a user demo who put it into our Gator chat, and then we stuck it on Facebook, and then I took it off from there. You can see it's doing basic reading of files, etc. FAT right now is probably, as far as FAT16, FAT32, we're probably at about 85%. And this is the kind of thing that's very easy to do. Any kind of developer could come in and help us with that. And you can see just in this demo, the drive is 0 colon. That's not a Cosmos concept. That's something that just the user built into his operating system, decided to name the drives 0. But they could be named whatever you want. You could make them ABC like Windows if you want. Now, these are what are called the Heisenberg items. They're both there and not there at the same time. So we have lots of users. We have several users who have written their own graphics drivers, but they're not integrated into Cosmos at this time because it's still kind of putting the cart before the horse. Now, if people want to do it, that's great. Right now, we do have one of the main developers working on a graphics structure and putting it in. So we'll have a base VGA and a VBE driver that people can build off of and use the other drivers. But right now, graphics, it's not supported, but there are lots of users out there who have made their own graphics implementations. And then I also built a UDP implementation, but it was quite a while ago and it hasn't been updated in a long time. So that one's kind of there, but not there. But if someone could update it, we could have basic UDP running as well again. As far as Edison, this was a demo we did. I think this was in 2014. Yeah, you can see right here the date, 2014. So we did this, and we're working on Edison for a while, but Edison really hasn't taken off that much, and the Raspberry Pi is really taking over. What we believe is that there's going to be two things. It's one, Raspberry Pi, and we think we're going to start to see more and more micro ITX boards based around a standard PC architecture rather than the Edison, which is slightly different. It's the same processor, but the hardware is different. And there's a lot of things at Edison that are just absolutely not documented, and Intel won't give them up. And there was a lot of reverse engineering that went into this, and we did have basic Cosmos stuff running on it. And I have the I have the Edison board sitting right behind my green screen right here, right now. So it is possible. If somebody wants to pick it up again, they can have all the code and we'll look at it. But right now, it's not a focus. So one thing that comes up a lot, people ask, why don't you have threads and why don't you have networking? Well, the reason is memory is not done yet. And these things really need memory. Memory is almost there. But there's a lot of other things that need to be done before we really jump on these. So yes, someday we will have threads and someday we'll have networking. And it's not even super far in the future, but older operating systems, DOS was not multi-threaded. All the 8-bit systems were not multi-threaded. Windows 95 was not multi-threaded. So it is possible to write a useful operating system without threads. But threads are on the roadmap. They're just not there yet, and we're putting them off because we don't want to, it doesn't help to make 50 things half done. It's better to do the 5 base things and get them done, solid, and then move on. So that's the reason it's not a design decision.
Okay, so correct me if I'm wrong, but it seems like one of the first workloads for something like that could be what people are doing with containers nowadays.
Exactly. And we've dreamed that from the beginning. In other words, for instance, let's say I wanted to set up a DNS server. And right now, what people do is they take one server and they put in a bunch of things together. They put in DNS, DHCP, web server, FTP, and they put all these things on one machine. But they could all touch each other. So instead, we envision Cosmos. Cosmos can do that if you want. If you want to deploy one server with everything on it, perfect. But because our overhead is so low, and with the ability to do containers, et cetera, our vision is that Cosmos could run on Pico servers, which are basically the size of a postage stamp. And they only do one thing. So you might deploy a server on discrete hardware or discrete virtualized hardware, and all it does is run DNS. It does nothing else. It only does DHCP. And that way, if something happens to that machine, it takes down one section, you can bring up a copy. So we're absolutely looking at Cosmos not only for normal servers, but Pico servers.
Yeah, and they don't need a lot of memory or disk space.
Nope, exactly. Yeah. Exactly. As we talked about before, we're getting a lot of interest. I mean, it might, I don't know if it's half, but it's at least a third of the developers that join into our forums and chat rooms. I mean, our teens or preteens. We have people coming in that are 10, 11, 12 years old. And in fact, the co-founder, when he started, I think he was about 16 or 17 when he started on the project. And he may have been 18, but he was still very young. And so we welcome people of all ages. We could use some help
That's
supporting these younger people.
Really awesome.
Yes, we're really proud of that. I really want to boost that. So if you're young and you don't know anything about operating systems, even if you don't know C#, join up. But we also need some people to help these people along, because I don't want to call it a burden, but it does take a lot of resources to teach someone operating system concepts when they're still learning C#. So we need some more people that can just help tutor these people along. And then, of course, we need some advanced developers too. If you have assembly language experience, et cetera, if we could get 3 or 4 more developers in the core, Cosmos would fly. Right now, here's what we're heading towards. I'm hoping to get this within the next year, but it really depends on how much help we get. We'll be .NET
machine,
Core.
yeah.
Yeah, that's a big one of mine, and that's more of a proof of concept of anything else. But I want to play Zork again on Cosmos.
Yeah,
so,
and once you're done with that, Doom, obviously.
Yes, well, that's a bit bigger. But once we get the Z machine, we can run Wishbringer, we can run all the Zorks, we can run all the Infocom games and more. We're almost to .NET Core. Visual Studio 2017, the RC is out. Once we get to the final, we'll switch over to that. And then there's going to be some work to move to the new project system, which will help us out a lot too, because there's a lot of code. There's so much code just working with Visual Studio. The Visual Studio integration was a massive amount of code, and the new project system should reduce that a lot. Hyper-V, that's not a big task. That's, a developer, this is the kind of thing, if somebody comes in and says, what's there to do? You could do Hyper-V. We can mentor you in it. It's very easy. It's probably, I don't know, a few hundred lines of code at most. And then there's Fat and Rat, which we talked about, and then the Z machine. That's 1.0. And then after that, currently, and after 1.0, everything is fairly fluid. But 1.1, we want to run on Azure. We want to get TCP, be able to run Zork over Telnet, and get an ARM compiler and be able to run on Raspberries and Pis. That would be really, really exceptional. 1.2, we're looking at VNC and Zork Web. And the idea behind VNC is it lets you remotely access any of the machines using a remote desktop. So instead of having to mess with NVIDIA and ATI for all these graphics drivers, if we get a base graphics driver, you just VNC into your machine, and who cares? You got a full GUI right there. Now, tangential projects, because people always ask us, well, isn't this like Singularity and everything else? Well, sort of. Well, Singularity, first of all, is deprecated and was significantly different in design. I mean, there were some overlaps, but their execution model was significantly different than how we run. The micro framework, sorry, go ahead.
What about Midori?
Midori, I'd have to look at the details. Last time I looked at Midori, we were still significantly different from Midori as well. But I have to look at their progress where they are right now. I completely forgot about that one.
Well, as far as I know, the project doesn't exist anymore. But
okay, I haven't followed it at all. So I guess if it doesn't exist, that would be a big difference.
Yeah, sure. But it would be interesting to understand what the differences were, because they had, they had their own language as well. So, and they had developed some really interesting concepts that made their way eventually into .NET. And
well, we did look at Midori. As I said, it's been quite a while, but we were significantly different in a lot of areas. We are not language specific, so we use any language that runs on .NET. And our execution model, the last time I looked at it, which was quite a while ago, is significantly different. We're really doing a lot of things down at the CPU level. If I remember, Midori still used a lot of the hardware protections and some other things, but it has been quite a while, so I may be wrong on that. The micro framework was completely interpreted. It's basically dead. It's open source, but it's minimally active. There are 3 developers on the project. They're all from Microsoft. There have been a few updates, but I don't really see micro framework being used by many people anymore. And then, of course, .NET Core. The difference with .NET Core and whether Linux and Mono is they're running on top of another operating system. So they don't get, all the security is still going to be handled by that operating system. You're still going to get that operating system underneath you. You're still going to have all the concepts of what that operating system has and brings. And you won't get the efficiency improvements that we have. And then you'll still be stuck. If you want to run a Pico server, you're still going to have the overhead of that operating system on top of it. Now, Linux, you can shave down pretty small, but I'm confident we can be even smaller than that. And then with Windows Core is just, that's a native operating system. It's basically Windows slimmed down. So we're completely different in design from that.
What about other platforms? Are there comparable efforts on Java or other platforms?
There is a project called, I don't remember exactly what it's called, but it's basically a Java OS. And in some ways it's similar, but where we would differ from them is, again, in their execution model. They're more of a standard execution model. And they do have drivers, et cetera, and they are farther along in some areas, but they don't have the debugging type of things that we do, first of all. And also it's Java. And I mean, I respect Java as a platform, but I don't, myself, I'm not fond of Java as a language. And with Java, you're locked in at the language. There are some projects that run their language on top of it, but the Java platform and Java language are fairly tightly integrated. And so whenever you don't use Java as a language, you have a lot of missing pieces and side effects. And so with us, the biggest difference would be, again, the execution model, but not only the fact that we can choose any language we want. We're not bound into Java itself. And the nice thing is you get to reuse tons of code. So if you have all your .NET code, at some point you'll be able to bring it over and run it on Cosmos. Now, we're not going to have WPF anytime soon. Okay,
Sure.
but WinForms, certainly we might have WinForms in the horizon at some point, and we plan also to have our own GUI framework, and we're also looking at things like Perspex. So if you wrote something against, say, Perspex, which runs on Windows, it's viable that it would run on Cosmos as well. And the framework we're developing for a GUI in the future will be able to run on Windows as well. It won't be as WPF, but it'll have a lot of the concepts, et cetera. So you'll be able to move your code back and forth. And aside from the parts that are WPF or the new, not Metro, but the UWP stuff, you'll be able to at least reuse the C# code itself. And if you've separated your application, whether you're using MVVM or MVP, MVC, et cetera, if you've separated your UI out, you'll be able to use all the non-UI code, unless, of course, it uses something like WCF, because we're not going to have WCF. But the raw code and whichever libraries we're able to support, especially libraries that are more managed, so like ASP.NET now is managed. These types of things, the more managed the code is, the easier it'll be to run on Cosmos. And if it's not fully managed, if it only has a few pieces, you can just plug those, well, we can plug those pieces, or whoever ports them can plug those pieces, and the rest of the code will run on Cosmos as well. So our main website here is www.gocosmos.org. Right now it just redirects to GitHub. We will eventually have our own website back up as well. All the links I'm going to show you here are on there. We have a Facebook page, which is fairly active. The most active area by far is right here, Gator. Gator is a chat client. It's similar to Slack. There's a web client and a desktop client and a client for your phone. We have 4 chat rooms. Feel free to jump in. If somebody doesn't answer you right away, don't worry, we'll get around to answer when somebody comes back. It's very active. There are hundreds of messages per day in the chat rooms. It's very, very active. And then on Code Project, I have several articles. You can just search by name or just go to this link, which will take you to my articles. We have a 3rd annual Cosmos Con coming up next year. We've already had 2, although the last 2 were very small. It was more of a virtual conference. It was the 2 co-founders, myself and the other co-founder. But we had a virtual conference, so we had people join in over the internet over Gator. This year, we're inviting more people. And you can see some pictures from the last Cosmos Con. It'll be in a nice tropical area if anyone wants to join in next year in July.
Nice.
And so that's the end of the slides. So we can go back to questions. Let me see if I can end. Okay, screen sharing. Or unless you want me to try and, if you have any questions, I can try to load something in Visual Studio and see if my audio will hold up.
Actually, we're almost out of time, but I'm blown away. I mean, I didn't think it was that big and that advanced. So I'm very pleasantly surprised by the project, and I hope that people viewing this will feel the same and will want to contribute.
I'm hoping we can get the word out again. Back when we started in 2006, we got quite a bit of coverage right away. That's when Singularity is still active. Mary Beth Foley, is it? Mm-hmm. She did an article on us. Yeah, Scott Hanselman did 1 or 2 articles on Cosmos. Yeah, those were 10 years ago. Mm-hmm. We've advanced quite a ways since then. And we're to the point now where we're really ready to start pushing again. And we need just a few more devs to really get to that 1.0. We could make it to 1.0 within a year, maybe sooner if we had a few more devs. Right now, all the heavy lifting is landing on about 4 of us. And it's right now, you can see the speed we're going 4 of us. But if we had 8 or 10 people doing heavy lifting, then we can really advance. And within a year, we could have networking and people could start to write small servers. Now, they're not going to be able to write everything or run everything, but it'll still be significant if you can run a small server and deploy it.
Yeah, that's very exciting. I really hope that we can help getting more people on the project. That's very interesting. If you want to make a guest post on the .NET blog as well, you're welcome to do that. Yeah.
Okay. I'd love to do that, and maybe we could do a follow-up in the future as we reach further goals.
Yeah.
And hopefully, if my internet improves, or maybe I can pre-send you the videos next time, and then I can just tell you which ones to play. Because my internet, I have internet from both the companies that provide internet here, and they both sometimes they just go down for 10 seconds. But when you're trying to do a live video stream, it's like poof, you're gone. And sometimes they don't fully go down. And I have a failover router, but when the connection doesn't go down, but it's only partially there, the router can't sense that, and it keeps trying to send traffic to the zombie connection.
I think we've been lucky today. The stream has been decent, so that's good. I want to thank you again for being on the show. This is fantastic, and I really want to encourage people to check it out and contribute if they can. Best of luck on the project. I'm very excited, very eager to see what it becomes, and please do keep us updated on future development. And if you have announcements, especially on the 1.0 version, happy to relay that. So thanks again.
Okay, we'll keep in touch, and just remember, any age, any experience.
Yeah, and that is a great message. I wish more projects would have a lot of young people like you do. Thanks again. Thanks everyone for watching, and we will be having a show next week as well. It will also be on Wednesdays instead of Thursdays. I think we're going to talk about MyGet next week. Bye, everyone.
Okay, bye. Thank you.